Today I'll talk to you about visual AI, spatial AI, and a little bit about generative AI. The primitives already at your disposal that are commercial ready and can be integrated into professional creative pipelines. Let's get into it. When I was 11, I saw this TV show called Mega Movie Magic, and I was just blown away that the same computer I was using to make dorky, cartoony animations could create visuals that were indistinguishable from reality. Then I spent a decade in tech, worked on everything from building VR camera systems to YouTube VR content to literally turning the world into an AR canvas for developers and advancing the next generation of Google Maps. So AI, while all of this may seem super groundbreaking, before I get into all the other stuff, I just want to ground it in something that I like to say is, this has never happened before, yet has happened time and time again. And so I would say spatial representations, which we're going to talk about, are perhaps one example. Whether it was like 1800s paper prototypes or Disney's, multiplane cameras or Google's multiplane images, you kind of see the essence of the same idea repeat itself again and again. I think the evolution of animation mirrors this pattern too. We had manual rotoscoping back in the day, and now we have AI-assisted video-to-video rotoscoping. And hopefully I can bring up quarter digital in a room full of VFX folks without people throwing tomatoes at me, because I've realized it is quite polarizing. But the trend is towards automation and ease of use. What once required super complex workflows, let's say in After Effects, is just a couple clicks in tools like Pika Labs. And so there's this democratization of esoteric visual creation, making it accessible to everyone. One quick example, the old way, like I make short form content on YouTube and TikTok, the old way for me to make things would be this sort of serial waterfall process that would take me about a week to do. If I use some of the generative AI tools, including After Effects and Premiere a little bit for polish, I can do what took me a week and do it in a day. And now, so you might ask, like, oh, we got all this extra time. Are we just going to all pull like a Tim Ferriss 4-hour work week and relax on the beach? No, we're not, of course. We're going to put more value on the screen, take on more ambitious projects. So, I created this video in January using the workflow I just described. It got 37 million views for some reason. And there was a moment in the zeitgeist where it made sense to make this video around like the Miami Mall incident. Look that up later. It's freaking hilarious. If it would have taken me a week to make this, I just wouldn't have made this video. And so I think we're going to start deploying visual creation in spaces, places, situations we would not have otherwise. Or to summarize, like indies can rival the outputs of studios, but studios will set whole new standards altogether because everyone gets these superpowers. So you might say, oh, blah, blah, that's a cute TikTok video. Like, what about AI primitives that we can get into higher end workflow? So let's talk about that. So in the meat of the presentation, I want to start off with spatial intelligence. Now, you probably heard about photogrammetry. It is the art and science of measuring stuff in the real world using images and other sensors. Spatial intelligence is also defined in the literature as sort of the ability to understand and interpret the spatial data, whether it's maps, 3D models, etc. Essentially, we're teaching machines to understand the 3D world that we live in every single day. And so, as I mentioned, photogrammetry is a new fact that predates computers, but what took data centers and sort of large teams of computer vision experts, it suddenly became commodity by the 2010s. Volumetric rendering and light field rendering isn't new either. But what is new is that reality capture has gotten a huge boost from machine learning. Essentially, these learned representations that can start modeling the complexity of reality, not just for measuring stuff, which was the initial goal of photogrammetry. Hey, let's do like surface reconstruction so I can measure the rooftop of this building or the size of this curb cut, etc. But to recreate the fidelity and complexity of the real world. So enter neural radiance fields. What you're seeing is an AI literally taking 100 2D photos off an iPhone and almost spitballing ray tracing to create this 3D representation that you can step inside, which is really, really cool because the initial NERF paper dropped in 2020. And just in the last couple of years, we've just seen insane progress, which we'll talk about shortly. But like I said, again, this didn't happen overnight. People just started paying more attention to it. There were other learned approaches. For example, I alluded to multiplane images early on, or MPIs, that paved the way for sort of these learned approaches to solving this pseudo light field-like problem. So with NERFs, basically, what is a NERF? I'll give you a very brief description. I also have a beautiful YouTube video on it if you're interested in that. Basically, imagine a voxel grid where every voxel has an RGB and alpha value. that changes based on the viewing direction. And so the novel part of NeRFs is really like you're learning these like spatio-directional RGB and like density values and kind of modeling the complexity of reality and the weights of this MLP, this multi-layer perceptron. All this sounds super fancy, but basically you have a neural network where you can query like every single voxel and do basic volume rendering to get photorealistic renditions of the world like you're seeing over here. And while it's not technically accurate, it is, I think, helpful to think about NeRFs as a neural version of light field photography. So all the stuff photogrammetry like had a hard time with, reflections, refractions, transparency, translucency, thin complex structures are all fair game. As I mentioned to crazy progress, NeRFs like took like, you're rendering at 1 frame per second on like a crazy GPU with like 24 gigs of VRAM. Enter Gaussian splatting, and now you can do it at 100 frames per second, which is amazing. And the big trade-off there, as you notice, is I'm saying an implicit representation versus an explicit one. 3D Gaussian splatting is also an example, sort of what Elena mentioned, is like, sometimes you don't need machine learning. You can just use statistical techniques, and that's exactly what 3D Gaussian splatting does. Like the paper uses terms like training, but there isn't really a neural network involved at all. So instead of this implicit representation with 3D Gaussian splatting, you get this explicit representation that is super easy to render. It's a bunch of these ellipsoidal splats called Gaussians, and basically think of it like NeRFs without the neural rendering bit. So this is crazy, right? Like suddenly what was like 1 frame per second just like 2 years ago, like if you look at the bottom left there, I'm getting like 400 frames per second on some of these captures. On the right, I've got in an Unreal Engine. And so like suddenly reality capture is a lot more practical. Why model something from scratch when it exists in the real world and you can do interesting things with it? And those view-dependent effects that I alluded to, right? Like, transparency, translucency, you can kind of see them in action over here as I like go behind this like backyard scan that I did, where you can see some of those light transport effects in action. And so, 3D Gaussian splatting models view dependency using this old physics concept called spherical harmonics. And so if you want to, do compression or whatever, you can prune those out and reduce your file sizes even more. So there's a bunch of ways you can play with this stuff. There are cloud-based solutions that are commercial friendly, Luma AI and Polycam, but you also have a bunch of local solutions so you can train on your machine, on premise. Postshot is one that's recently hit the scene. That's what I'm visualizing over here. Super friendly GUI. It almost reminds me of the UI for like Agisoft Metashape or like reality capture if you've used one of those tools. NeRF Studio is amazing, where some of the models are commercial friendly, some of them are not, but has like both a command line interface and a GUI if you want to just like duct tape your own pipeline together. And then finally, if you've never made a splat, one thing I would encourage you to download if you have an iPhone is just go download Scaniverse on your phone. I talked about this trajectory from like frickin', like 2021, I had to like go get a bunch of TPUs in the cloud to train this stuff to, 2022, NVIDIA dropped instant NGP and I could do it on one machine. Then Luma AI hit the scene where I was still using GPUs in the cloud. Now you've got Scaniverse that's taking advantage of like the beefy Apple chips on the iPhone, and you can train entirely locally. In fact, it'll start splatting in real time as you're capturing it, so you get this real time feedback loop, and the data doesn't leave your device, which is kind of wild to think about. There are other things, interesting things you can do on device as well, is like, there's modeling the complexity of reality, but other times you also need a useful abstraction of reality. In other words, creating this sort of like simplified, semantically meaningful 3D model of a room that represents like the walls, like the room itself, like windows, furniture, basically a 3D floor map. And this uses Apple's Room Capture API, which is also commercial ready. You could build it into your own apps. And so if you're using it for surveying, you need to quickly capture something on set, you could use the simplified geometry to place objects later, but you could also use it for like projection mapping, light occlusions and other things like that, a good starting point. The other cool thing about, kind of these explicit representations of 3D Gaussian splats is like manipulating them, right? Like if you're dealing with this black box implicit neural network, like it's super hard to edit it in traditional tools that you might be accustomed to. 3ds, like most of these, kind of like softwares will output a PLY file, a Stanford PLY file. Super easy to bring into whatever else you're using. There are plugins for, obviously Unity and Unreal. There are editing tools, Super Splat and Spline. And actually, you've got plugins for After Effects as well, PostShot, and iRealX just dropped this past week that lets you bring splats directly into After Effects as well. And gosh, I mean, if you've got to, go talk to your TD, I think it'd be like a week of work to do a 3DGS implementation or whatever the hell else you're doing. It's actually, that trivial. But again, with this explicit representation, you can edit it far more easily. And if you have any like point cloud shaders out there, you could very easily adapt those to start working with these type of things. And so what are folks doing with it? Well, static radiance fields are already being used in music videos and commercials. And so 2 music videos you see on the left over here on the top, you've got R.L. Grimes. On the bottom, you've got a Zayn Malik video. And these videos are like almost doing like kind of bullet timey effects, or they're leaning into almost like the interesting like artifacts that you get from these radiance fields. In other words, like radiance fields degrade far more gracefully than like a photogrammetry mesh, and you can do interesting things, especially if you're going for like a dreamlike aesthetic. On the right, a beautiful example by Cody Kurth for the NBA. They made like this super janky GoPro, like 34 GoPro capture rig, and just did some very, very cool things with it. Of course, y'all are professionals. I do want to bring up like dedicated capture systems that also produce radiance fields. So LiDAR surveying is very common in professional settings. And honestly, LiDAR SLAM, which is like sort of the way AR tracking works on your phone, like simultaneous localization and mapping, like building a map of your room, figuring out where you're within it, and constantly refining that map. LiDAR SLAM has gone a long way since Cartographer SLAM, if you're aware of that, since the 2010s. And so with tools like the Lixil L2, which is by this company called XGrids, if you want to look them up, basically give you both. You'll get that LiDAR colored point cloud, but you will also get a 3D Gaussian splat. Which is kind of cool because like, I want to show you this capture. This was done in 15 minutes, like this whole capture. Like, so if you're like, I don't know, you're the VFX super, whatever, like, DIT brought on set to very quickly do a capture. It's like, oh yeah, you have like 5 minutes to do this scan. Like, best of luck with your photo, like, kind of RGB camera rig to, get a good result. You can take a capture system like this. This one uses a more sophisticated LiDAR sensor that does millions of points per second, and then has an Insta360 camera with a 1-inch sensor for RGB attached to it. So you kind of get the best of both worlds, and it's pretty amazing how quickly this is being adopted. Like all the people that were hesitant to get into radiance fields, because like, I don't want to deal with neural networks, are now adopting radiance field, and it's very, very exciting and perhaps something worth evaluating. We also have to talk about like volumetric capture rigs, right? Like we got Mike Seymour in the audience here. Paul DeBevic's probably floating around somewhere. Like dedicated capture systems and light stages have been around for a while. And sort of in the consumer world, the race is on for, these tech companies to essentially own your 3D avatar, like the embodied representation of you in a variety of different constructs. I'm not going to use the metaverse word, but, Meta's got like codec avatars. Apple's got their persona avatars. And of course, Google's working on Starline. But with that, what we're also sort of seeing is a resurgence in other types of capture. If you remember, like 4 or 5 years ago, there was an explosion in interest in like Intel set up a capture volume, Microsoft set it up, they licensed it to some places, like some of those shuttered down. But it was all videogrammetry, right? Like the video version of photogrammetry. And like, as cool as it was for the time, even if you bake in your normal maps or whatever, like it still looks like freaking GTA, and it kind of sucks. Like it's, unless you really like lean into sort of like if you're going for some like cyberpunk aesthetic, it kind of looked like crap in my opinion. But radiance fields, again, are breathing new life into these dynamic spatial capture systems. And this is where the research is still very early. Like I would say like static radiance fields are very mature. There's some promising early research on like dynamic 3D or 4D Gaussians. And, key point being there's like tremendous opportunity for optimization. And so like, if you ever dealt with these videogrammetry systems, like the atlasing, the UV unwrapped atlases would just shift so much from frame to frame. It was like almost impossible to do any post-capture stuff in it. Like all of those problems are being refined now in this kind of radiance field world, because a bunch of other techniques for like frame to frame and object tracking have just advanced a bunch. So Infinite Realities does this. Look them up. They're based in London if that's of interest to you. So another thing I want to talk about is like when people think of spatial intelligence, like if you, I'll pause here. Oh, where's my cursor? There we go. If you built a 3D model of the world, you can do interesting things with it as well. So, we talked about this like human readable model, which you see on the left, like the photorealistic 3D world. We talked about sort of abstracted representation, sort of the room plan where I don't want all that data. Like there's a geoinformatics, like freaking office next door. There's like in the GIS world, this format called city GML, like which is used for a lot of like, kind of like land allocation, city planning, things like that. But there's also this machine readable model, right? So if you start building these maps of the world, you can do very interesting things with it, such as querying reality. So, you probably use GPS every single day. There's another technique that's out there right now that's called VPS, Visual Positioning System, right? And so the idea here being you take that machine readable model, you take a photo of the world, and what's happening under the hood is ML is used to extract features that are consistent over time. So this works across like weather condition, time of day, all that stuff, and match it up against that 3D model, sort of the representation you see on the bottom right. And here you can see like the relocalization accuracy is like really good. It's like sub-meter positional and like a couple degrees of rotational accuracy. And so like this is used heavily now, like for again, micromobility companies are using it. Like the AR industry is obviously using it. Like it's inside of Google Maps, but like the entertainment industry is not really using it for surveying. They'll give you one example of a company that is. Well, the wild thing about it is it's like available in 100 plus countries. 100 plus countries, basically everywhere with Street View has been mapped with this level of detail, and it's free. And so like, what can you do with that? Like there's also another beautiful thing out there that's called Google 3D tiles, right? Basically all of Google Earth data, and I had a chance to work on this with Patrick Cozy and the Cesium team that spoke earlier this week, available in this open format called OGC 3D tiles. So you can bring it into Unreal, Houdini, whatever you want. And so if you take something like VPS and start combining it with 3D tiles, you can make an amazing surveying app. So whether you're sitting remotely and you're like, oh, that's a location, we want to put the camera there, we want to capture plates over here, let's go do this, that, and the other thing, these 3D annotations will show up perfectly when you're there in the real world. Or conversely, when you're in the, let me just replay this video again. If you're in the real world and you place annotations, you can go back and see that global view and have everything available for you in places, so what does that mean? You could start querying like 3D tiles for coarse grained geometry, terrain data, lighting information, other attributes that are sort of location specific, which is super exciting. And so, of course, another thing you can do with this type of, localization or snapping is you could take your like, Scaniverse scan or your DSLR scan and snap it against that model, sort of like Cesium's illustrating here. So you've got your high res, like 0.5 centimeter, 0.25 centimeter, like high quality NeRF or radiance field. And then you've got like, like the 3D tiles for context. So you don't have to go capture everything in the city. The rest has been done for you. And so one cool tool that's doing this is actually called Cyclops. They both integrate the geospatial API as well as 3D tiles. So if you want to take a photo of it, some of you are already, it's like really, really cool. Like you can frame your shot like, oh, what is it going to look like when we're right there by Big Ben? Where do we want to place our angles? Like where's the sun going to be? Are we going to be in the shadow? Where's, all that type of stuff you can do. And what's cool is then you can start recording these as like FBX files or USD files and then bring them into your existing workflows. And again, conversely, if you're there in person, you can like literally turn on the 3D tiles and see it lined up with like sub-meter accuracy with what the camera viewfinder is saying. So you could do a bunch of interesting things with it. I'm sure there are other problems, like production problems that you could solve with this stuff, but the primitives are out there free and waiting to use. The 3D tiles is paid, but it's fairly cheap, I would say. All right, let's switch gears to visual intelligence. All right, so visual intelligence, I'm going to define as like basically teaching machines to perceive and understand the world and the contents within it, right? So basically understanding and being able to act on imagery, you can kind of view both of the buckets, like sort of like the spatial visual stuff as like, it's classically called computer vision, which is a subset of artificial intelligence. But these tasks such as estimating human pose, depth estimation, like coming up with physically based rendering shaders, semantic or panoptic segmentation, things like that. And so what's funny to me is like, especially having spent some time in big tech, it's like a bunch of folks from the VFX industry were slurped up to like basically deploy all of these stuff like as on-device models for like friggin' Snapchat filters. And now we have sort of like, oh, cool, a hot dog can dance and you can become a hot dog. But now the reverse is happening where these models are being optimized for professional use as well. And so like one example is obviously Wonder Dynamics. And so they're bringing monocular pose estimation. And, the funny thing is a lot of the training data, which Elena alluded to earlier, was really optimized for like monocular captures off your cell phone because that's how this stuff was used. Wonder Dynamics is training their models off of cinema cameras with a variety of different lens configurations, narrow, wide-angle lenses. So you'll get a much better registration of like an estimation of your pose and better precision on recall versus if you use something like off the shelf for, full body pose estimation. So that's monocular. Move AI is another interesting company that's doing multi-view pose estimation. So you've got multiple views of the scene simultaneously, and it can be anything from like a friggin' bunch of iPhones that you put on like, a couple of like monopods or tripods, to GoPros, to if you really want to go like, professional FLIR, like global shutter cameras with like frame or line level synchronization. And then with one like A6000 GPU, you can get real-time results that are really, really interesting and amazing. And so then you get this mocap data, and then using tools like Cascador, you can use more interesting like physics and ML-based approaches to sort of modify that data for more, and tweak it rather than dealing with noisy keyframes and so forth. Next, I'd like to start talking about sort of reskinning and sort of relighting and sort of segmentation, all the cool stuff you can do. On the left, obviously, as you can see, I'm using just AI to relight myself to fit in a virtual environment. And on the right, I'm using depth estimation to kind of take this like blocked out like play blast render from Maya and just trying different styles on it with generative AI. And so a cool company I want to point out in this space is called Beeble. It's a South Korea-based company that has a close partnership with the AI lab in NYU. And basically what they do is given just like monocular video of like whatever like subject matter you give it, they'll basically delight it and give you like a PBR shader. So they'll give you your albedo, specular, like normal, roughness, all that good stuff. And, it can still have this sort of like cadaver like quality to it. I'm sure like, it may not pass the litmus test for a lot of y'all. And if you want to go the next step, they offer a neural rendering solution where they try to emulate those light transport effects. What's cool about their research though is like they figured out a way to scale outside of light stage data sets. And so like, even if you use something like portrait relighting on your Pixel phone, like a diverse set of subject matter like went into the light stage that Paul set up like in Playa Vista, and like a bunch of captures were done. But like, how do you go even beyond that for all types of subject matter? They found a clever solution, and that paper is online as well. And so this can run locally or in the cloud, and they do offer API access. Now, speaking of API access, if you want to give that relighting a try again with your iPhone, like I like to say it's cool to go and like explore these things later, but just like literally on your iPhone, if you go download Skyglass, you can try a bunch of these primitives. You can do segmentation. You'll have a cloud streamed Unreal Engine environment streamed into, which is kind of wild to think about. And then when you hit off your render job, it'll use the Beeple API and relight it for you and give you a bunch of different passes that you can play with as well, which is really, really cool. So it's kind of wild, like prosumers are getting these tools so quickly, which like, as a kid, I could have only dreamt of. All right, jumping on to like the state of the art in dense pixel segmentation. Elena talked about the segment anything model, which is very interesting because like she talked about like a billion images, like it basically generalizes to anything. Like you don't have to have like specific label data for like a bunch of semantic classes. And that itself started a bunch of like interesting research that was built on it because again, SAM is commercial friendly. If I'll check, segment anything is released under Apache 2.0. And then what I'm going to talk about here, track anything is under an equally permissive MIT license. And so Track Anything is a video object tracking and segmentation tool based on Meta SAM. And in my opinion, it's better than like Rotobrush, certainly anything else that's out there. And like the robustness of the tracking is amazing. And so like if y'all sat down with your own like, like pipeline experts and made something that like vectorizes this output where you could still get that like fine grained control, it's going to be better than anything else out there. And I believe this example, uses E2FGVI. Researchers have a knack for not naming things super intuitively for in painting as well. And in my opinion, it looks better than content-aware fill, certainly in After Effects. So these are primitives out there that you can build with. In the startup space, like ex-VFX folks, there are other interesting companies like Electric Sheep is trying to train their own models. They got a bunch of POCs with a bunch of VFX studios to sort of try and rival, Nuke and DaVinci Resolve, and certainly blows Runway out of the water. It's interesting to see that, of course, Segment Anything is not on this comparison list. And if you do want to play with Segment Anything, by the way, in After Effects, there's a plugin called Mask Prompter that you can go play with. It's a little unstable, but might be a cool way to just dabble with this stuff if you don't know your way around like a Python command line. Keeping in this line of foundational models, another really crazy paper that came out, funnily enough, from ByteDance is called Depth Anything. This is also under Apache 2.0, so you can build commercial stuff off of it. And basically this trend of using unlabeled large-scale data, in this case, the frickin' treasure trove that is the TikTok catalog, has been used. And sort of overnight, we got this foundational model that generalizes to all sorts of scenes for monocular depth estimation. And, similar to the trend, as I mentioned earlier, this didn't happen overnight. So, if you go back and look at some of the models trained off of, remember the mannequin challenge on YouTube? That was a very interesting data set to extract static objects, get depth from various directions, and then train models off of it. But waiting for you to use. And right now, the way it is being used is Vision Pro is super hot lately. There's a tool called Spatial Media Toolkit, which just literally does all the processing again locally to do 2D to 3D conversion. If you throw your brains at it, imagine what you could do to automate the 2D to 3D conversion workflows and a bunch of other stuff that you could do where you need depth estimation. An interesting tool that isn't quite out there, but I've included it because they, at least the CEO told me that they've got it's in early access starting next week, is Simulon, which really brings the best of a bunch of these primitives that we're talking about, capabilities like image-based lighting estimation off of a very narrow field of view, monocular, or low dynamic range image has been out there. Debevik et al. Did Deep Light, which is obviously an AR core. There's a similar model that's in ARKit. Those are the SDKs for Android and iOS, respectively. The interesting here is just doing it for higher production value use cases. So you go capture, your space very quickly, and you've got this LDR panorama, and then you turn that into this HDR pano. And then also, since we talked about sort of SLAM tracking, since this application is using not just vision, so you're probably used to having high shutter speed, trying to use global shutter cameras to get a good 3D solve. If you are using the IMU, you can get some amazing rock solid tracks like this. And they're working on a way to synchronize and deal with sort of the lack of synchronization between phones and cameras as well. And again, this is a place where this would have been a very hard problem, but now ML is making this stuff a lot easier. Wonder Dynamics is taking sort of a similar approach, right? You basically you can go into their tool, do monocular, pose estimation. You can do lighting estimation. You can do in painting, but then you do one-click export into Maya, Blender, Unreal, and then you get everything set up. And I mean, as an artist, how exciting is it to have all that heavy lifting done for you? Maybe it's 80% of the way there, but now you're in Unreal or Maya or whatever, and you've got that last mile, last meter, pixel level control that you are used to, which I think is exciting. The other big update I'd love to talk about here with Wonder Dynamics is most of these pose estimation algorithms happen in screen space, so they're not in 3D. They're sort of relative to the camera view that you're looking at. They recently updated that so that now you will get a 3D solve of the environment, and things will be sort of in world space and scene space coordinates, which is kind of cool. All right, this brings me to the last leg of this journey. Looks like I am doing well on time. A bit on generative AI. I think the next speaker is going to talk a lot more about Gen AI, and the prior speaker did already. So I'll just say a few things here, which is, before Sora came out, I thought we'd need a hybrid approach. I was you're going to need the explicit control of a 3D engine, and maybe diffusion is sort of a new way of sort of taking it all the way. And if you want consistent characters, entities, whatever, you need to condition it with sort of this 3D scene graph that you have explicit control over. And then Sora came out, and it's similar to Elena's trend of let's just throw more data at the problem. Of course, if you want to see a funny video of the OpenAI CTO asking about what data set this was trained on. I think that's a pretty funny video. You should go check it out. It sounds like it was trained off of YouTube, but the response is fairly ambiguous and publicly available data, whatever that means. And what's interesting though is like, instead of Unreal working, say, in concert with like sort of these generative AI models, what's fascinating here is like, they're just taking a bunch of synthetic training data out of Unreal and like, training off of it. So if you look at the cherry blossom scene in particular, you'll notice that people move with this consistency of like the Matrix metahuman scene in Unreal. It looks very uncanny. This is totally like conjecture here. But I think like vast amounts of synthetic training data and the fact that these companies have built their sort of funding cycles off of more data and more compute runs is like, I think we may be surprised with what these sort of more, what we may call like naive approaches would result in. And, when I saw this video, I'll just replay it. This is the one that like, oh yeah, cool, like puppies with like snow and blah, blah, blah. I don't care. Like this I saw, I was like, holy shit, this is what I do on my TikTok. And like a 1-minute video is like exactly the type of length that I aim for. And imagining doing this the good old fashioned way would have been like nuts, right? And it's like, and sure, like, I post this on Twitter and people are like, well, like, it doesn't look that good. And like, here's all these 10 different problems. It's like, well, that's literally the checklist for researchers to fix in the next iteration. And like, what would I add to the scene? Okay, yeah, maybe there would be bubbles. That feels like something, if you really understood a world model and this person's underwater, maybe there would be plankton. But those are things that would be easy enough for me to add and deal with. Here's a Sora video that you probably haven't seen. So it was a pleasure for me to co-host the AI session at TED in Vancouver last week with some amazing AI luminaries. And so this is something my buddy Paul Trillo made, imagining what the TED conference would look like in 40 years. And I mean, just imagining like doing this the good old fashioned way again would have obviously taken a lot longer and maybe wouldn't have been as like exciting. The one thing that freaked me out was like the growing the meat scene. I was like, I'm totally cool with like growing 3D models, but I draw the line at growing the meats. But maybe that's just me. So that's like all the visual stuff that gets a lot of attention. I think what isn't talked about enough, especially in the creative and the visual space, is like multimodal AI systems writ large and like even like friggin' large language models. And the framing I would encourage you to think about this stuff is really to think about generative AI as like content to content. Whether you have text, image, video, and 3D data, you can transform it into text, image, video, and 3D data, and every permutation and combination therein. And, so like Gemini, like Google likes to call it anything to anything. And I think that's just super, super exciting. Like you can even do crazy things like screen record your After Effects screen and then be like, yo, write like a After Effects script to replicate what I just did. Like how crazy is that? Like I haven't tried this for mail scripting in Maya, but I encourage you all to go try it. It works for Blender beautifully as well. And so think about the various ways of automation, like automation workflows that you could think about. And the context windows are getting massive, right? So, one of the things Elena said also earlier was like, yo, like, it's a hard problem, maybe don't do it. Like, and in this case, like, I think even things like fine tuning models and like RAG, like retrieval augmented generation is like, there are many use cases where I think you needed that I don't think you do because with like models like Gemini and like literally you could go to aistudio.google.com right now and like just play with this stuff and like make a bunch of TPUs per, you've got a 1,000,000 token context window. And for context, that's like all the Harry Potter books, like multiple hours of video footage. It can also reason over audio. So, I mean, like I dropped in like a freaking driving tour of San Francisco that was 55 minutes. And then I had a timestamp just tell me every single landmark that it saw. And it gave me a really, really good rendition, right? And so imagine as a part of this like iterative feedback loop where clients seem to think like changes can happen till the very last moments. Like what if you could ingest all your shot notes, your scripts, your storyboards, and yes, indeed, that client feedback too, and then synthesize it, right? At the very least, I think you'd have happier visual effects supervisors and production managers, but you could also distill down those insights for artists and let like all these knowledge management systems everyone talks about on-prem or whatever, like you're probably using some variation of Microsoft, Google, whatever for your like internal Slack. And by the way, Slack like if you look at the terms of service, they are absolutely training on your data. So just FYI, by the way, is basically all this data is already digitized and probably in the cloud already, probably at some like much higher quality enterprise tier. And so you can start deploying these models like Gemini or GPT-4 or whatever and start using it, maybe not for the stuff that like Disney or Marvel would never let leave some like server room in some nondescript location, but all the other stuff that surrounds making that content. What you can also do is like reason over multiple clips. So like if you create a bunch of generations, so like here's the criteria I want you to look at, and then go filter down like, I don't know, this like asset library of 100 things, let's say. Find the 10 best clips that I should be evaluating for this purpose. You'd be surprised how good of a result you get with some of these multimodal models like Gemini. All right, so in terms of visual creation itself, I just talked about how Sora could be amazing, but also it turns out like Sora takes like an hour to generate a 1-minute clip and like, has a bunch of like A100s purring in the cloud. And so of course that'll be optimized and it'll get faster and maybe it'll follow the same trajectory we saw with radiance fields from like massive numbers of TPUs to the friggin' iPhone in your pocket can do it. But I still think for explicit control, which I think what a lot of creators do want for a lot of different scenarios, I think it's going to be this hybrid approach, right? So you'll be mixing classical 3D and VFX compositing tools with the generative stuff. And so I wanted to pull up this example by Eric, aka 8BitE, who has an amazing YouTube channel, by the way. If you want to get into these, like, how do I do a hybrid Blender, Maya, like comfy UI workflow? Definitely check out his work. It's all like this. And I think the most interesting stuff will probably be done this way, because if anyone can type in a text prompt and make that stuff of like easily, like it's just going to get boring very quickly. And so I think like as that sort of floor rises, the ceiling will rise too. And it's like content like this that'll break through it. But again, to just counteract my skepticism, Jensen Huang, the NVIDIA CEO, seems to think the opposite. He's like, well, sorry, like I think every pixel will be generated in the future. And, I had a chance at GTC to actually ask him about this prediction and be like, can you put a timeline on it? And as he'll read in some of these like Tom's Guide and other articles, you'll see he give this very meandering answer about like the innovation S-curve, but he seems to think it's like 5 to 10 years out and we're like 2 years in. And so maybe just like your NVIDIA GPU does like deep learning supersampling or DLSS, maybe there'll just be a chip on your computer that does that for you. Maybe that'll be the same way ML-based denoising is used in sort of traditional ray trace-based rendering solutions. And we'll sort of have a meeting in the middle that will give us that artistic control, but also give us space to sort of, get a lot more speed rather than, somebody was talking about the Pixar folks had a talk saying like, yeah, Toy Story like took us this long to render. Now we take like order of magnitude more time per frame than we did back then, which goes back to the point of we're going to put more value on screen, but to make that compute accessible, not just to Pixar, maybe this hybrid approach will be the way. And I will say 5 to 10 years seems like a very tame prediction by Jensen here. I think it could be a lot faster. So if I speculate a bit, what does that mean? And we've got this like chip on your, on your computer that just does this for you. The Midjourney CEO likes to say video games will basically be like, it'll be a AI chip in the cloud and we'll be playing dreams essentially. So that's interesting to think about. And so if I speculate, I think we'll be authoring content at this like higher level of abstraction. And an interesting analogy for me is like HTML and like sort of the document object model. If you're familiar with that, or if you're like a 3D nerd, let's just say a 3D scene graph. So again, you like just exert fine-grained control on the stuff that matters, and then you outsource all the rest, right? Like if you think about like the commercial and advertising space, the last mile customization to get that 1 15-second frickin' ad localized to a bunch of different regions for a bunch of different variations is just insane. And that's all largely done manually in these like super duct tape pipeline. And so you can imagine all the drudgery that we'll save if you have authored content at this higher level of abstraction, like, I don't know, like some, friggin', let's just say Toyota ad. And like, you can change out the background, the talent, the subject matter based on like whether this is in like Seoul, South Korea or Mumbai, India, right? All that customization can happen. Now, there are scary aspects to this too, but I'm sure we'll talk about that stuff on the panel. So in summary, in my opinion, I think you need to start investing in all forms of AI today. Like spatial and visual AI, like this stuff is commercial ready to go. Like you should be building plugins and doing awesome stuff with it right now. generative AI is early, but honestly, all the large language model stuff that isn't sort of tied perhaps to the ethical concerns of scraping the whole internet, whatever. For some reason, blog writers are way more okay with their stuff being scraped, but not the New York Times. If you follow that lawsuit, I think it's important to start playing with it, even if it's not for visual creation, but all the things surrounding it that inform that visual creation process. And the coolest part of all of this is, unlike every other wave where you've had this like technological lock-in effect, oh, we're a Maya shop and we've got like frickin' decades of like, Maya-based, kind of pipeline tools that have been built out. For large language models and generative models, it's very easy to swap these things out. I mean, like, you're literally describing a bunch of these, instructions in like natural language. And so there is no lock-in effect. It's zero switching costs. So like, oh, you love Gemini, you used it for prototyping, but you want to do it all on-prem? Well, Llama 3 by Meta just dropped. Go run Llama 3, fine-tune your own version of that, and use that on-premise. And so I think that's very exciting. So a lot at your disposal, amazing available tools. And I think also I will say, to shamelessly plug back to the start, an opportunity to create new tools. So again, if you are going to build something, are building it, know someone who's building it, an accelerator program with the funding that I mentioned for $750K over 12 weeks is of interest to you, definitely go check out Speedrun. Again, that's the URL, and feel free to take a photo, email, and we can talk about it later. And with that, it's been a pleasure to be here, and hopefully y'all walked away learning something new. Thank you.